Okay, well, welcome back. What we're going to talk about now is function notation. So, definition here: function notation is a method of replacing a y. Instead of y equals, we have something called f of x. Okay, f of x, kind of here, as you can see, is f of x. It's just an f parentheses x. Or g of x, or h of x, and they're all represented by that letter parentheses x. Okay, basically, it's just a way to identify functions by name. Okay. So we look at the problem number 3, and problem number 3 is talking a little more story problem in your notes there. Just throw that at you. Is that a function represents the number of words you can read in X minutes. So it's a function talking about reading in so many minutes. Now the way they write it is that we have some function that's w of x is equal to 250x. And basically how we would have seen it at the beginning of the year here would have been y equals 250 times x. That's really the same thing. The w of x is just another way to write it. So they want us to solve for w of 8, which is basically how much can you read in 8 minutes. So a fancy way of saying this is that it's just giving you information. It's basically telling you what to plug in. So up here we would have just said, when x equals 8, tell me what y is. Okay. Well, here that's what they're saying. This is really what this is saying. When x is 8. So notice how the x went from being in the problem to being an 8. So we're going to take the 250 and we're going to sub in 8 for that x. And then we're going to have 250 times 8 gives us 2,000. So w of 8 is equal to 2,000. Now nothing happens to this part. Notice that we didn't do anything there. It's not an operation. That's just the instructions. Okay, so we can say what this is really telling us, when we plug in 8, so our x coordinate is 8, we get 2,000, our y coordinate. Okay, so that's really all it's doing. So notice the left side we did not touch. We only took the 250 multiplied it by what was in here. That's it. Okay, so it's just function notation. And we'll get more and more familiar with that because we hit that really hard in Algebra 2. Okay, so the next thing is to talk about domain and range. As we talked about, domain is a set of inputs. Range is a set of outputs. So x and y values basically is what we've been saying. We have a function called f of x. It's equal to negative 1.5x plus 4. Well, they want to know what happens when we plug in, or they're telling us our domain is 1, 2, 3, and 4. Which is basically they're telling us our x values. So really we could say we have a coordinate 1 something, coordinate 2 something, coordinate 3 something, and a coordinate 4. All we have to do is take these numbers, plug them in for x, and solve for our y coordinate. So if I were to take, in this case, 1.5, negative 1.5 times 1, and then add 4, I'm going to get 2.5. Okay. If I take 2 times negative 1.5 plus 4, I get 1. If I take 3 times negative 1.5, I get negative 0.5, and then negative 2. And again, all we're doing here is saying negative 1.5 times 1 plus 4 is equal to 2.5. Basically, it's just finding your x and y values. So my range, as we go through, my range is 2.5, 1, negative 0.5, and negative 2. So because they're just giving us a small list of numbers, we're just going to write our domain and range as a small list. Okay, we're not describing at this point, which we'll get more in that as we get farther along in algebra. Okay, so you just plug in the x values, the domain they gave you, and solve for the y's. That's really it. I mean, that's what we want to know. What are the y values? Okay, so example 2, really the same thing. I want you to go ahead and do on your own. Okay, we'll talk about that in class. Okay, problem 5 talks about identifying reasonable domain and range. So talking a story problem, making sense of this. You have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 feet square feet. Okay, the function a of q is in square feet that q quarts of paint covers. So q represents paint, quarts of paint that we'll cover. Okay, what is the domain and range that is reasonable for this problem? So basically, as we talk about it, if you have 3 quarts, what's some reasonable inputs? So basically, what can you talk about in terms of this problem? Well, I have a 3-quart can, so I can talk about having really no paint. Okay, I can talk about having 1 quart. I can talk about having 2 quarts. I can talk about having 3 quarts. I don't have 4, and I can't have negative paint. So basically, I have every value between 0 and 3. Because I can't have a half a quart, I can have 1.5 quarts. So what we're going to say is the amount of paint I have is greater than 0. So Q is greater than or equal to 0. So 0 is less than that. Okay, or excuse me, I should say and is less than or equal to 3. Because if I use all 3 gallons, that's it. I'm out of paint. Okay, so this is my domain. That's what's reasonable in this problem. Okay, so what's our outputs? What's our range going to be? Well, if you think about it, if I use no paint, how much square feet can I paint? Well, obviously nothing. So we can say our range, which is going to be represented by A sub Q, or A of Q, is going to be definitely greater than 0 or equal to it. Okay, so I'm just going to use a function notation, just saying my square feet that I can have. But it's got to be less than, if you think about it, if I use all 3 quarts of my paint, I've covered 300 square feet. So there's 300 square feet. So that's my domain and range. How did I get that? Well, again, I went through and said, well, how much paint do I have? So that's how I got that. I can use no paint, I can use up to 3 gallons, or any combination in between, okay, 2.5, 2.3 quarts, things like that. Now my range is, again, by how much paint I use, determines how much square feet I can cover. Okay, so basically when we come over here to this graph, what I'm going to do is I'm going to plot my point 0, 0. No paint, no square feet covered. Now, again, I'm going to use, going along the bottom, is going to be my paint used, and over here is going to be square feet covered. Okay, so 0, 0. If I use 1 gallon, I use 100 square feet. So let's jump up here and say this is the 100. And let's go over 1. There's 1 gallon. Okay, so I'll say this is 1. So I want to label that because I'm counting by different units. 2, I get 200. So I can plot that point there at 200. And then 300 if I use 3 gallons, or 3 quarts, excuse me. Okay, I better label that to be correct there. 3 quarts, there we go. Okay, and there's my line. Now again, if I go and draw my line, I'm going to stop there because understanding this story problem, once I'm out of paint, I'm out of paint, so I'm not going any farther. So really, I don't want to draw that line any farther than what it is. I'm just going to go from these 2 points because that's all I have. Okay, so we talked about our domain, we talked about our range, and then we graphed that. And again, it stops there. Okay, so that would be continuous, but it's stopping at a different, it's a finite number. Okay, so that's really it. We're going to talk more in class tomorrow. We'll get into going over some problems. We're going to work together a little more. I want to try to get a little more examples in class, so we'll talk more when we get into class.